All right. I'd like to welcome those of you who may be joining us. We're just going to wait a couple of minutes here before we get started to allow everyone else to join us as well. Okay, I'd like to welcome everyone to another installment of the Wireside Chat produced by CTI Connect. And today we are joined by Joe Schrammel of CI Microelectronica to discuss the next generation of backhaul architecture that is multiband. So Joe, would you like to just give us a brief intro on yourself and the company?
Sure. Good morning, everyone. And those of you on the West Coast, or those of you on the East Coast, good afternoon. I'm Joe Schrammel with CI Microelectronica, and thank you for our friends at CTI, Sasha, Tyler, Joey, for allowing us the opportunity to come visit you and tell you about the company and our solutions that we offer here with microwave and millimeter wave. So a little bit about me before we get into the microwave and the multiband stuff, the E-band stuff. I've been involved with microwave radio since about 1985. Actually, it's building these radio systems for a company called Avantech while I was going to school, working in the factory, tuning radios. And this is back when radios were in 7-foot racks. Number of projects here in the US. I actually built the radio systems for the Kaiser Hospital Foundation, or the Kaiser Hospitals here in the San Francisco Bay Area. And then they hired me to come and work on them and maintain them as part of the network. So we actually had at one point in time the largest private microwave network in the country, linking all the hospitals and medical office buildings here in Northern California. I'm actually based in the Silicon Valley here. Interesting story about that. I was at the NOC at the time we had the 1989 Loma Prieta earthquake. Some of you might remember that was an earthquake hit San Francisco pretty hard. It was actually during, I think, Game 3 of the World Series between the Giants and the A's. But interesting story about the microwave. We didn't lose a single link during the earthquake or after the earthquake. Although you saw some of the destruction, the superstructure, the marine fire. The really cool thing about microwave is that the network stayed up, which is a testament to using microwave systems in your network there. As I saw that firsthand working for Kaiser at the time. Post Kaiser, I've worked for a number of companies, digital microwave now, Aviat, PCOM, Comtech, EF Data, Bridgewave. All in all, almost 40 years of experience in the microwave. I've done pretty much everything from working in the factory to doing field support, on-site field support, pre and post sales, marketing, product management, and I've been with CI Microelectronica here for the last 7 years. Enjoying working with the microwave systems. Been doing it for a long time.
Thank you. So let's get into the multi-band discussion here. So as wireless networks are becoming more and more robust and the bandwidth requirements are ever growing, can you help us understand the need for a multi-band solution in a today network?
Sure, sure. And Joey, I digress here just a second. I gave the audience a little bit of background about me, but I should have also included a little bit of background about the company, who CI
Okay. Yeah.
Microelectronic is. So let me just
Sure.
digress here, and
Hmm.
I'll tackle multiband in a second. So for those of you who are new to CI Microelectronica, welcome. We're actually a 70-year-old Italian company founded in 1952. Just outside of Milan, Italy. It's kind of the Silicon Valley of Italy. A lot of radio companies there. Marconi's there at the time. Alcatel-Lucent, now Nokia, but it's a pretty high tech part of Europe. We've been producing microwave radios. We started off producing broadcast transmitters in the 50s and 60s, and migrated that to analog systems in the 70s and digital radio systems in the 80s, and literally for the last 50 years been producing microwave radio systems in Italy here. We've grown the company over the years. We actually acquired the optical arm of Alcatel-Lucent back at the end of 2014, rebranded that SM Optics. So we're bringing those products to the US starting later on this year. So we'll be also offering optical products as well as the microwave radios that we sell. We're a privately held company. As mentioned, we're headquartered just outside of Milan, Italy, in a town called Cologno Monzese. We own our own factory. We've actually got two factories, one in Italy, one in Romania. So we build our own radio systems. We design them. We do all in-house, the design, all the hardware, all the software is done in-house. And then we've got the two factories where we can build our radio systems. We've got about 1,500, almost 2,000 employees worldwide. Here in the US, we're one of 26 subsidiaries. We're all subsidiaries of the parent company. So we're owned, we're all privately held. The three brothers who run the company, one in engineering, one in finance, and one in operations, they're all the sons of the original owner, Eduardo Marchetti. And so they like to say that we answer to customers and not shareholders. So it's a nice, refreshing change compared to being a publicly traded company where you've got pressure for EPS and dividends there. In our factory, we have the capability of producing around 12,000 transceivers a month. So we can certainly spit out the radios quickly. And then we're in almost 100 different countries around the world here. Some of our global references, we do a lot with the tier one mobile operators worldwide. So companies like Vodafone and Telefonica are major customers of ours in a number of countries that they serve. Also companies like MBNL, Everything Everywhere, SFR in France, Etisalat in the Middle East, Telefonica in Spain, MTS in Russia, looking at Asia Pacific, China Telecom, Maxis in Malaysia, Telstra in Australia. And then here in the Americas, CI services, companies like Sprint/T-Mobile, Frontier Communications, as well as we're sold through distribution partners, CTI being a partner of ours here in the US. As mentioned, we have our own factory, so we do our own design that helps us with the build, the quality, the improved yields, being able to manufacture these in mass. Our engineers are right there in case something happens, but it allows us greater control and flexibility in bringing these products to market. And then finally, here in North America, we chose Dallas, Texas as our North American headquarters. So we have a 30,000 square foot facility just outside of the DFW airport. We're actually physically located on DFW airport property, but we maintain inventory there. We can augment what our distributors and CTI doesn't have on the shelf. We can do drop ships from Dallas. We also maintain our tier 1, 2, and 3 support facilities there. We have engineers there in Dallas that can help troubleshoot, help you through configuration. You don't have to call Italy. We do all our RMA stuff. All our training is done there. We have a full lab that replicates any of the configurations, any of the products that we sell here in North America, so we can easily walk you through configuration and be able to get you going with the guys in Dallas here. Okay, so that's sorry about that. I did digress, Joey. A little bit of hopefully gives you guys a good idea of who we are. We're fairly new to the North American market, but I think the takeaway from this is that been around a long time, a lot of experience with microwave radio systems. And so, don't be afraid to reach out to your CTI rep, your CI rep, certainly answer any other questions you might have about the company in the background. But let me talk about the need for multiband. So I think that's kind of the biggest buzzword in the industry now today. As I mentioned at the start, I've been doing this for quite a long time. Multiband seems to be pretty prevalent across the customer base, across the manufacturer base. You see everybody talking about combining radios to achieve higher capacity. But why do you do that? So wanted to just hit on the market drivers for multiband. I think the biggest thing in multiband really is the migration from 4G to 5G networks. So you hear a lot of people talk about network densification, and that's really where you have a 4G macro cell that may take up a radius of, say, 3 to 5 miles. And all of a sudden now you're trying to cram more data. You've got the folks using the cell phones as video devices, as games now. So how do you get multiple gigabits a second across that same area? Well, you have to densify the network, which means you're adding a lot more smaller cells to a 4G cell site. So, for example, where you might have one 4G cell site, you might have 5 or 10 5G cell sites within that same radius here. So then, your networks are becoming more dense, and with that, the backhaul needs need to increase too. So where you might serve a 4G cell site, with a couple hundred meg or a gig, that's not going to work with 5G networks. So the operators are understanding that you have to provide those fat 10 gig pipes or fiber to these 5G base stations. So that's probably one of the main drivers as we start to look at the need for multiband is how do we get that multi-gigabit connections to all these cell sites in the network. Another driver is just the increase in capacity on the networks today. So, how many of you on the phone call, how many of you on this video chat have a smart device in your home? You've got maybe a Nest or a Ring doorbell. You're checking who's at the front door while you're at the office. Maybe you've got a Nest thermometer, set the temperature while you're in your house while you're driving on the way home from work. But we're all connected now through what we call the Internet of Things, or IoT. So even things like refrigerators are now smart. You've got a number of other appliances in your home. You've got even on airplanes, trains, things like that, even your automobiles. I saw a commercial the other day for Chevy, where the two guys are taking a drive in their Silverado up the mountaintop, and they're enabling Wi-Fi in their truck so that they can do remote work. So the IoT is certainly driving that. And as you're doing that, you're needing more capacity on the backhaul. And that's where these multi-band links are coming in. And then the third driver here, let's talk about video services. Maybe 10 years ago, there were just a few examples of companies doing video services in demand. Netflix, certainly YouTube, but now you've got Roku, Hulu, Amazon Prime has got their own video service, Slingbox. So that is also driving the need for more capacity on the network, and the need for fatter pipes to serve those 4G and 5G cell sites as people are using more data. So just to contrast, maybe looking at Cisco every year puts out a VNI Virtual Networking Index report. So I went back and looked at that from 1992. 1992, they were saying that the consumers worldwide in 1992, 30 years ago, were consuming 100 gigabits of traffic per day, internet traffic per day. And 5 years later, it was 100 gigabits per hour. 5 years later, in 2002, it was 100 gigabits per second. So, and then in 2022, that 100 gigabits per second, 20 years later, or this year in 2022, they're estimating almost 151,000 gigabits per second, or 151 terabytes per second of internet traffic, not per day or per hour or per week or month. That's 151,000 gigabits per second of internet traffic. So that really exemplifies the need for these bigger, fatter pipes and the need for multiband backhaul, Joey.
Right. Yeah. Yeah. So many of our operators pretty much operate like single band solutions, whether that be licensed microwave or E-band as a standalone. And this has its advantages, but it also has its challenges. So can you address what those are?
Sure, sure. Yeah, so we all know today that the best way to get data from point A to point B is by a wireless backhaul solution. And then there are many differences, many different options as you look at these wireless backhaul solutions. It could be licensed, unlicensed. Back in the day, there was free space optics, although not much anymore. But looking at licensed microwave backhaul solutions, people are looking to those solutions mainly for the interference protection that you get from using a licensed backhaul solution. Now, what are the differences? Really come down to what are my capacity needs? What are my distance? What are the distances I'm traversing with these links? What kind of target availability am I looking for? Certainly features, price, performance, all that factors into it. But when we look at licensed microwave, some of the pros of using licensed microwave really are you can achieve those long distances. And at one of my prior companies, we had a link connecting two islands in Hawaii over 70 miles with over water using licensed microwave. And so being able to extend those distances, multi-miles, tens of miles, is certainly possible in connecting point A, especially now as we're starting to look at companies that are getting RDOF funding, the rural funding for rural networks, using microwave to connect those small towns that may not be able to be serviced or may be hard to be serviced by fiber. As I mentioned earlier, interference free. So when you use licensed microwave, you get a license from the FCC, and you're pretty much protected. You're the only one using those frequencies, and that gives you a lot of protection against interference that you might not get in an unlicensed spectrum. You can plan for carrier grade availability. So if you have mission critical data, maybe you're a government entity, you're needing that 5 nines availability. You can plan those microwave links to have that same 5-minute per year outage that the carriers would plan their microwave links to. So you can certainly have that flexibility. Maybe different frequency bands, antenna sizes, all that stuff. One of the biggest things about microwave, whether it's microwave or E-band, though, is it's relatively quick to deploy compared to, say, a fiber solution. So where you might have to trench fiber, where you might have to go point A to point B, go down a city street, rip up sidewalks, or do an aerial fiber run, that takes time, permits, etc. Microwave can be installed very quickly within a matter of days, and notwithstanding the license process, and get your service up and running very, very quickly there. It's future proof too. So you might only need 100 megabits today, but all the systems today on the market allow you that the future proof availability to maybe upgrade the link down the road, enable capacity. Maybe I only need 100 meg today. I'll pay for that, and then as my network grows and my backhaul needs grow, I unlock the features in the radio to get me up to a gig or a gig plus. And the other pro about the microwave here really is that several different architectures available. So you've got a lot of customers will install. It's all enclosed in a small outdoor form factor. So you can install that form factor, that small outdoor radio on the back of the antenna, run a couple of cables to it, and off you go. But we also have options in the industry for customers who might want to put the breadth of the system indoors, and just all the signal processing, the switching, etc., all indoors, and then just run a cable to an outdoor unit that essentially does the up conversion there. Some downsides to the microwave systems. Today they're getting a lot better from when I first started in the industry. You can get microwave radios today that'll do up to 2 gigabits per second per carrier, and you can cascade those to get multi-gigabit systems today. But so when you're looking at needing 10 gig per second speeds, the microwave not going to reach those 10 gig per second unless you start cascading or we're putting multiple links together. Unlike an unlicensed system, they say this is a downside. I don't think it is, but you've got to plan your links. You've got to make sure your links are engineered correctly. You've got the right frequencies, the right transmit power, the right antenna sizes. Factor all that in to make sure that you're designing your microwave system to give you that reliable performance. And then on the other side here is that some people just don't like to deal with the FCC and do licensing form. Not really a negative, but it's just some connotation there that I've got to go deal with the FCC. There are companies out there that offer those services too, so it's not really a detriment. So that's on the microwave side. Let's take a look at the E-band side. E-band. So when I talk E-band, I'm referring to the frequency spectrum from 70 to 80 gigahertz. Actually, 71 to 86 is defined by the FCC. Those frequency bands, that frequency spectrum, allow you multiple 10 gigs and then multiple 1 gig. You can get a lot of traffic over that link in an E-band system here. Again, interference free. The really nice thing about E-band is that with the frequency that it operates in, the antennas are really limited to say 1 or 2 foot. Anything more than 2 foot, you've got very narrow pencil beam antennas on the 3 dB beam width on the order of about a half a degree. So having that very narrow beam width antenna really helps you put a lot of links in a small area and avoid interference. Back in my Bridgewave days, we had over 700 links in New York City, all using the same frequency, but doing things with the polarization. We were able to do that because of the very narrow beam antennas there at 80 gigahertz. So excellent interference immunity with the E-band radios. Again, you can plan for 5 nines availability. You can do it quickly. Get these E-band links installed in a day. Same future-proof things we talked about on the microwave. Start off with maybe just a gig and then upgrade to 10 gigs as you need. On the downside, the E-band is a challenge because it's so high in frequency that your distances are really going to be limited as a standalone. And we'll talk about multiband here in a second here. But if you're just deploying an E-band link on itself, here in the US, you might be limited to maybe 1 or 2 miles, maybe 3 miles, depending on where you are in the country, how much it rains, and what your target availability is. So really short distances on the E-band side. And then if you want to extend that 10 gig range, or you want to extend those distances, you've got a cascade links to go multi-miles there. So adding to the cost there. But the biggest detriment on the E-band links is really rain attenuation. So if you're in places like Miami, you're in places like the Gulf states, or you're going to see very high rain attenuation. You get into some of the western states, say from Utah out west, your rain attenuation is going to be a lot less. So what that means is very short distances in the Gulf states and probably in the Northeast, slightly longer distances on the West Coast. Now on the license side, it's what we call lightly licensed. So again, companies out there can help you with that. CI, we can help you with that too. We've got a nationwide E-band license. We can tuck that under our license, but the license is good for 10 years. And same with the microwave. The microwave license is good for 10 years. So those are some of the pros and cons, some of the differences between how both microwave and E-band operate on their own, Joey.
Right. Great. So, as our listeners may have guessed, the multiband solution is really reaping the benefits of both of those solutions, both license and E-band. So can you get into a little bit of how that works and how, what it is?
Yep, absolutely. So as Joey said, when we talk about multiband systems, it really gives you the best of both worlds because now we're able to combine properties of the performance of E-band with the performance of the high capacity performance of E-band radios with the extended range performance of the microwave system in one single solution that benefits the customer, as you've got 10 gig links that instead of going 1 or 2 miles, and now you can stretch those 10 gig links 4 or 5. We actually have a customer in Utah doing it at 9.6 miles, almost 10 miles there with E-band with the microwave augmenting that. But ultimately, what that does for you is it allows you to operate 10 gigabits per second during unfaded rain conditions, or unfaded conditions, or when there's no rain. And then if you think, it only rains, 99% of the time, it doesn't rain 99% of the time. Then you're chugging away at 10 gig, except for that 1% of the time that it's going to rain, and then that's when the microwave kind of helps you out there. So the big benefit to multiband is being able to extend the E-band distances farther, but being also able to provide those 1 gig SLAs, if you will. If you're a service provider, you can provide 10 gig services, and then if you got a customer that really is interested in SLAs, okay, I can augment the E-band radio with a microwave radio and still provide you 4 nines, 5 nines of 1 gig SLA, all done seamlessly here. So what that means to the user is that you've really just got one cable from the system down into your switch or your router here. We do all the magic up on the tower where we bring the E-band and the microwave together. Now think about this. So when you're transmitting 10 gigabits per second over your E-band link, I'm trying to do this here, with my hands here. You can see you got 10 gigabits per second with the E-band link, and then on the microwave link, you've got 1 gigabit per second. So the challenge is not so much on the transmit side, but how do I reassemble the packets during a rain fade when my packet processing is 10 gigabits per second here, and only 1 gigabit per second on the microwave side. And then really that's where our secret sauce is with CI, is being able to reassemble those packets on the receive end in sync so that the customer, it's seamless to the end user. It's all done at layer 1, and there's no degradation in performance. We prioritize the high priority traffic so that your voice and video will still come over the link. Some of the data may buffer, but during a rain fade. But at the end of the day, the ability of our multiband solution, or the magic of the multiband solution, is being able to let the customer have both worlds. That 10 gigabit fat pipe during unfaded normal operating conditions, with the ability to still prioritize and have that high priority traffic go over the microwave link during times where the rain may be too intense for the E-band system, but the microwave system will still operate. So in essence, really what it does is our microwave solution augments the E-band radio, and I use the word augment a lot. I don't use the word fail over or switch over, because we're not failing over, we're not switching over traffic. We're just augmenting the traffic from the E-band system to the microwave system. And then when the rain fade subsides and the E-band link comes back up to its normal operating RSL in conditions, all the traffic is passed over the E-band link seamlessly too. Okay.
And can you touch on a little bit? I think you made a pretty good point there. Can you touch on the benefits, or maybe what are the disadvantages of a true failover system? Because I think that's really important to understand.
Yeah. So let's talk about the architecture of the E-band system, because I'll answer that question as we talk about the different architectures.
Okay.
So
Yeah. Want to go? Yeah.
Yeah.
Essentially, we can dive deeper into that,
Yep.
and because operators, they want to know how what they should consider when installing, because that's a big part of this.
Sure.
So yeah.
Sure. So let's take a look at the solutions on the market today. So I categorize them into 3 types of solution. There's the single all-in-one box solution. And then there's a second solution is an E-band radio with a 5.8 gigahertz backup. And then there's an E-band radio with a licensed microwave backup, as we do with our multiband system. So let's talk about the single outdoor unit, the solution first. That solution is great because it's convenient. It's one radio to install. Certainly because you've got one radio to install, you have a lower price for that one radio. And because you got one radio to install, you're going to put it on the back of one antenna and then have one antenna to align. So from a convenience standpoint, that single ODU solution is nice. Now there are some drawbacks to a single ODU solution. The ones that I'm familiar with on the market today don't have the same performance as, say, a separate box solution. So you're not going to have the same transmit power at E-band. You're not going to have the same microwave performance in the sense that you can't do XPIC. You can do two carriers, but they have to be on the same pole, which means you've got two licenses to buy. There's really no redundancy. So if that single box, the processor or maybe the 80 gigahertz transceiver fails in it, the power supply fails in it, that whole link is down. It's dead. There's no redundancy, no resiliency to it. And then with a single antenna, we'll talk about this subsequently, but single antenna doesn't provide the same performance, the same gain as you might have with separate antennas here. So if you're looking at an 80 gigahertz 2-foot antenna, there's going to be some degradation in gain because you're trying to use that same 2-foot antenna across a very wide set of frequencies versus being able to focus the energy on a narrower set of frequencies. So single ODU solution, good for some folks. There are folks using it today. But again, it's also got some challenges too. Now let's talk about the E-band with the 5.8 gigahertz backup here. More often than not, that E-band and 5 gigahertz backup is going to be a two-vendor solution. So you have a vendor for your supplier for the E-band radio, and then you have a supplier for the 5.8 gig radio, not necessarily the same vendor. So there's going to be some challenges with that. The biggest challenge is, as you mentioned, Joey, in switchover time. So there will be a certain point in time where the E-band radio signal fades to a point where the Ethernet traffic has to switch over to the 5.8 gigahertz radio. Now they say the switchover time on that is 50 milliseconds, which is a standard for 64 kilobit voice back in the day. But think about this: at the 50 millisecond switchover time, when you're pumping 10 gigabits of traffic over the link, you're losing 500 megabits of traffic during that 50 millisecond switchover time. So that video that you're watching is going to buffer. That phone call that you're on is going to drop. Just because you've just lost a huge chunk of data during that switchover. The other thing about the 5.8 solution is that you are using a 5.8 solution that is probably a couple hundred megabits per second. Trying to back up or trying to switch over a 10 gigabit pipe to a couple hundred megabits per second, it's certainly going to not give the end user, that same performance, that same end user feel that he has when he's got a 10 gig pipe. In addition to the fact that you've got a TDD system versus an FDD system. So what happens when you switch over to that 5.8 system, your latency goes up, especially if you're extending longer distances. As you know, you extend longer distances on a TDD system, that the time because of the distance in between point A and point B, that latency is going to increase. So you've got the much lower throughput, higher latency, and you've got that 50 millisecond hit on the as you're switching over from the the E-band system to the unlicensed 5.8. The last one we just talked about, and this will really focus on here on the presentation today, is the E-band with the licensed microwave. So as I mentioned previously, 10 gigabits E-band, where we can augment that traffic with a licensed 1 or 2 gig microwave link. With this solution here, this allows us to use a number of different microwave frequencies. So we can use 11 gigahertz, we can use 13, we can use 15 in Canada, for example, 18, 23, 38 gigahertz. And if we really got our druthers about it, we could probably do it with 6 gigahertz too, but I'm not going to advocate that on the call. That gives us the flexibility to plan the microwave link to have a really highly reliable path. Again, it's seamless. I mentioned earlier, we do the augmentation, we do the layer 1 packet processing. It's upgradable. So, if I'm an RDOF winner, maybe I want to install the microwave system first and get some traffic going over the link. And as I start adding users and adding more customers and my traffic needs increase, I can add the E-band system at a later date. So I don't have to do it all at once. That's one of the nice things about this two-box solution. And it gives us some redundancy. So what happens if the power supply in the E-band radio fails? Well, I've got to replace the E-band radio, but I can still have traffic going over the microwave link as I'm doing that. Whereas in a single box solution, I'm dead in the water. I've got nothing going between point A and point B, and I need to go fix that ASAP. And then with the microwave solution, we have the choice of doing a single antenna, as we do on a single box solution. So I can put both the E-band radio and the microwave radio on a single antenna, or I can do 2 antennas here. So maybe I've already got the microwave system up, and I want to augment that at a later date with the E-band system. I can add that at a later date without affecting the microwave at all. Or maybe I'm in a congested area and I can't get an 11 gigahertz 2-foot antenna in a congested area because 11 gigahertz at 2 foot is category B rated. So I can go ahead and use a 3-foot antenna and use that 3-foot antenna on my 11 gigahertz link and use the 2-foot antenna on my 18 gigahertz. And I have that flexibility to allow us to do that with the licensed microwave solution. Now, it's a 2-box solution. Certainly, it could be more expensive than a single box solution, but I think you're going to find that the performance benefits of a 2-box solution, the flexibility of a 2-box solution, the redundancy you get in a 2-box solution is certainly going to become a factor in which one you want to put on your network. Okay.
So the other thing I think that you may have mentioned, but maybe just to reiterate, there may be some folks out there who are looking at, say, the benefits of the single antenna because it may drive down the cost of install if they're paying rent or something on the tower. And so, but there are benefits of doing 2 dishes, even though it doesn't seem that way at face value. And can you touch on a little bit of that and why that is?
Sure. Yeah. With a single antenna, as you mentioned, Joey, it's convenience, right? It's 1 antenna to install, 1 antenna to align. And if you're leasing space on a tower or a rooftop, you're only paying for that one antenna profile that's on the tower here. So it has the ability to maybe save you some OpEx versus a 2 antenna solution. On the downside, think of this as for those of you who are on the call are familiar with filter design. Okay, what happens when you design a wideband filter? So you're going, what happens? You're designing a wideband filter. The gain or the insertion loss of that filter goes down because you're trying to get that filter to cover a wide range of frequencies. So in essence, what we say, your Q goes down. When you're designing a very narrow band filter, you're not worried. Your insertion loss is a lot less than it would be if a wideband filter. So you've got a very high Q filter there. This is a similar concept with antennas here. As I'm trying to focus the energy at a wide range of frequencies, maybe from 11 gigahertz all the way to 80 gigahertz. As I'm focusing that energy across a wide range of frequencies, my gain is going to go down because I can't be as efficient in putting the energy into the parabolic reflector than I can with a single frequency. So I'm going to lose some gain on a single band antenna. And at the E-band frequencies, the specs I've seen from the vendors, it's about 2 dB loss relative to the same size frequency specific 80 gigahertz, say 2-foot antenna. And that 2 dB per antenna translates to 4 dB per link because I've got to have antennas on both ends of the link. So I'm going to have degraded performance. At 11 gigahertz, I mentioned previously, at 11 gigahertz, the antenna will only be a category B rated antenna. So if you're trying to put these into congested areas where the FCC says, no, you need to use a Cat A antenna for your 11 gigahertz license, that single antenna is not going to work. You're going to need to maybe use a 3-foot antenna to be able to comply with the FCC requirements of being a Cat A for that license here. Now, the single band antennas I've seen actually on the market today are actually higher in price than separate 2-foot antennas, one for 80 and one for, say, 18 gigahertz. So you're actually going to pay more for a single band antenna. And that's really a function of there are very few suppliers on the market. I think as other vendors come online with their dual band antennas, you're going to see the prices of dual band antennas come down. But today, there's only a handful of them doing it, and they're able to charge a little more for that single 18/80 gig 2-foot antenna. And then finally, with the single band antenna, some radio vendors will require you to reduce the modulation on the microwave side. So if you've got a microwave system that's running at 4096 QAM, because that antenna is not as efficient, there's going to be some additional group delay that within the system, the overall RF system, that antenna will cause you to have to back your modulation down to, say, 2048 or even 1024 QAM, just because of that. So again, pluses, multiple pluses, multiple minuses. One antenna install, OpEx costs, etc. Now let's take a look at a dual antenna. The dual antenna, as mentioned, gives you the ability to have the highest gain both at E-band and microwave, because those antennas are focusing the energy only at E-band and then only at microwave. So I'm not having to worry about a degradation in performance. I can plan my links further and have higher availability because of the higher gain in the antennas here. As mentioned earlier, it gives me the ability to be flexible and plan those microwave links where I might need a 3-foot antenna because the FCC says I can't use a Cat B antenna in those instances, so I can use a Cat A antenna there. The OpEx costs, as mentioned, the prices for, say, an 80 gig 2-foot and say an 18 gig 2-foot. Those prices, I think, are actually lower than, say, a single 18/80 gig single band antenna. And as we talked about earlier, this allows you the flexibility to upgrade in the future. So maybe I've got an 11 gigahertz link or an 18 gigahertz already between point A and point B, and I'm maxing out that capacity on that 11 gigahertz or 18 gigahertz link. I don't have to do anything with that link. I can go ahead and add an 80 gigahertz link with a separate antenna at a later date, and then have that 10 gig pipe augment, or having that 10 gig pipe going back between point A and point B, and then using the microwave to augment that. Certainly you have 2 antennas to install in a line. That's a one-time thing, and certainly you're going to have maybe additional capex or OpEx costs, excuse me, if you're leasing space on a tower or a rooftop for a 2 antenna solution. So there are pluses and minuses to both there, Joey.
Right. So I think we'll move over to some Q&A and field some questions here. Joe, if you can see there, if there are any questions there to take from our listeners.
Yeah, here's one. Can you describe the interconnection between the 2 radio systems? Yeah, very, very simple. So picture we have the E-band radio on the tower and the microwave radio next to it. We run a 10 gig fiber from the switch or the router to the E-band radio. Now we could also run another 10 gig fiber to the microwave radio, but I would, in the switch, I would disable that switch port because I don't want to create a loop. I would activate that switch port only if I ever had to replace the E-band radio and I wanted that traffic to go over the microwave system. But the interconnection between the two is real simple. We have a 10 gig fiber. We have another fiber port. It's a 2.5 gig fiber port. So we have a 2.5 gig fiber port on the E-band, a 2.5 gig fiber port on the microwave, and we just have one small fiber jumper between the two. So where that allows the E-band traffic and the microwave traffic to do their magic, let's just say, and be able to augment the traffic between the two. So very simple interconnection. In fact, like as mentioned earlier, if you've got the microwave system, it's very easily upgradable. You just take the 2.5 gig ports and run the fiber between them as you're upgrading. Boom, you're done. So there's not much to it there.
Right, right.
Uh,
I think we
Another
get
question here. Yeah, actually, another question here, Joey. What's the power consumption of? What's the power consumption of these radios, and can I use PoE? Great question. So I'd like to talk about the microwave system first. So our Alpha Plus 2 radio has got the lowest power consumption of any microwave radio on the market today, 73 watts, and that's with both carriers enabled at maximum power. I think if you look at the next radio on the market today, it's about 90 watts. And then there's higher power versions of those that are at say 135 watts. The E-band radio takes about 50 to 55 watts. So all together, when you combine the AP2, we call it the Alpha Plus 2, I call it the AP2, and our 80HDX, which is our E-band radio, looking at a total power consumption of about 120 watts. Yes, they can be powered by direct DC feed, but the other cool thing about these radios is that you can also provide PoE power to them with each radio having its own PoE injector. And you can do that simultaneously. So if you've got if you've got a critical site, maybe a mountaintop site hard to get to, beautiful for solar applications because of the low power consumption of the microwave system. Run both DC and PoE to them. So if you lose the PoEs, the DC still feeds it. You got the DC's on battery backup, where the PoEs might not be on a backup or might be on a generator. So you can do that and have that ability to have the radios powered simultaneously. Don't see many other vendors doing that on the market today. The other interesting thing about our microwave radio system is, as you're powering up the microwave radio system with PoE, there are some vendors out there that require you to back the transmit power down as you're using PoE, especially on longer runs of cable. We don't do that. So if you're running 328 feet of Cat5 cable between the PoE and the radio, our radio is still going to pump out maximum transmit power. We don't ask you to back the power down because we're compensating for the DC resistance of a long Cat5 cable. So yes, we can power them up through PoE, we can power them up through DC, and we can power them up simultaneously for an added level of redundancy to the system there.
Right, right. All right. Well, I think we could probably wrap up a little early here. Yeah, I do want to mention the promotion. Added benefit of attending the webinar today, you have our listeners have access to special pricing on the CI multiband solution, and they can go by way of contacting their rep or just our sales department to kind of start that conversation. And there's many individuals at CI we can bring in on a technical call, deep dives, and anything else we want to explore, and just to better understand what a solution will cost you, how to install it, and all that. So I want to thank Joe Schrammel for entertaining us today with a lot of information on this particular solution. And if there's anything you'd like to add there, Joe, let me know. And
yeah, Joey, I just want to say thanks to everyone for joining us today. I hope the information that we provided was helpful. You got a little bit out of it today. You learned a little bit more about CI and who we are. Our company the products that we bring to market. So we have a portfolio of microwave and millimeter wave products, all licensed to Backhaul, been around for a long time, US support, but more importantly, thank you, Joey. Thank you to our friends at the CTI for allowing us the opportunity to come and visit with you today. I appreciate the partnership and the time today. Any questions? Certainly our staff here. Mike Kemp on the East Coast, Joel Columbus on the West Coast, Randy Montoya, Augie Lucenti, myself, our support guys, Al Naja. Certainly happy to help you with any questions that you have on CI. And again, thank you for the opportunity. And I'll just wrap it up and say, make it a great rest of the day and coming up on the weekend and have a great weekend too.
Yep, absolutely. And we'll also share this recording, after the fact. So if anyone has any people who want to hear this, please share it with them. It'll be live or it'll be reshared on social media. And there will be a brief survey as soon as we end here. So I'd appreciate if you guys could share the feedback, and if you need any additional information, please request it. So thanks and have a great day, everyone.
Great. Thanks, everyone. Bye-bye.